this is where we left off with our Hess's law equation, okay? And we are going to move along. Just a second here, we need to get rid of Hess's law equation. All right, we're going to move along to the enthalpy diagram for that combustion that we just did. Before we start that, I want to point out to you that when we figure out our total enthalpy, to sum it up really quickly, it is the sum of the products minus the sum of the reactants. Now, before we go and take a look at this chart, I want to remind you that our enthalpy for our equation was a negative 890. Doesn't want to write up there. Negative 890 kilojoules. Okay? It was negative. That's the important part. It was negative. Okay? So if it was negative, does that mean there was more enthalpy for the products or more enthalpy for the reactants? Well, let's take a look at it. Let's say that, we'll just throw in some fake numbers. Let's say that our products had an enthalpy of 3 and our reactants had an enthalpy of 1. That would end up, if we subtracted those two, we added them together, which would end up being a subtraction, that would end up with a positive 2, right? Let's switch it up. Let's say that our products had a enthalpy of 1 and our reactants had an enthalpy of 2. Okay? You'd end up with a total of, 3. We might as well keep the numbers the same. You would end up with a total of negative 2. So in order to be exothermic, which we have, we must have more enthalpy from our reactants. And if you look at this chart, that's what you find out. You find out that the reactants are up here, way up on this enthalpy scale. They have a higher enthalpy than the products do. Okay? But notice that there's a sum here. Okay? There is a sum of 2 reactions. You've got this reaction where it originally goes to our gas water. Then you have that water has to turn into liquid. So you have this reaction, and the both of them equal the total reaction, and the total 890 kilojoules. Okay? So, moving on. Maybe. Oops, we went the wrong way. Hold on. Hess's law. Hess's law states if a reaction is carried out in a series of steps, the delta H for the overall reaction will equal the sum of the enthalpy changes for the individual steps, and that's what we just did. So your job now is to look over the sample exercises that are in your book. Okay? You look over the sample exercises. They're the ones that are in the yellow kind of color on pages 186 to 188, and be ready because when you come to class, we are going to be doing a bunch of these Hess's law problems. All right? See you guys later.